Let's explore the standard equation of a circle on a coordinate plane. This equation will let us precisely define any circle using just its center point and radius. Every circle has a center point. We'll denote its coordinates as h, k, where h is the x-coordinate and k is the y-coordinate of the center. The radius, which we'll call r, is a fixed distance from the center to any point on the circle. This constant distance is what defines a circle geometrically. A circle is defined as the collection of all points in a plane that are exactly radius r away from the center. This equal distance property is what gives a circle its perfect round shape. Let's consider any arbitrary point on our circle, which we'll label as x, y. This represents any of the infinitely many points that make up the circle's circumference. By definition, the distance from our center point h, k to any point x, y on the circle must equal exactly r. This key constraint is what we'll use to derive the circle's equation. To express this distance constraint mathematically, we use the distance formula derived from the Pythagorean theorem. The square of the distance between 2 points equals the sum of squares of differences in their coordinates. This gives us the left side of our equation, open parentheses x minus h, closed parentheses squared, plus open parentheses y minus k, closed parentheses squared. The h and k in our equation represent the x and y coordinates of the center point. We subtract these values from x and y to calculate the horizontal and vertical distances from any point to the center. The x and y variables represent the coordinates of any point on the circle. For a point to be exactly on the circle, its coordinates must satisfy our equation. Since the distance from the center to any point on the circle equals r, and we've expressed the square of this distance on the left side, the right side of our equation must equal r squared. The Pythagorean distance formula connects the left and right sides perfectly. So our complete equation is open parentheses x minus h, closed parentheses squared, plus open parentheses y minus k, closed parentheses squared, equals r squared. This elegant formula is the standard equation of a circle, expressing the fundamental property that all points on the circle are equidistant from the center. This equation completely defines our circle. Any point whose coordinates make this equation true lies exactly on the circle, and any point that doesn't satisfy the equation lies either inside or outside the circle. For our specific circle with center at 1, 2 and radius 2.5, we can substitute these values into the general equation.